What's up, guys? Today we're doing a video on the empirical rule and normal distributions. A normal distribution is a data set that if you look at its distribution, in other words, if you were to do like a dot plot for the data would kind of be stacked up in the middle and it would form a bell curve. It's a type of bell curve specifically called the normal distribution. The empirical rule describes that distribution like this. It says in a normal distribution, 68% of the data is within one standard deviation of the mean. This symbol mu, it's a Greek symbol mu, means mean or average. 95% of the data is within two standard deviations of the mean, and 99.7% of the data is within three standard deviations of the mean. Another property of normal distributions is that the mean of the data set is in the middle and it's symmetrical on both sides. So what this means is like most of the data is going to be lumped up here in the middle, and the further you get away from the mean, the less data you'll find out there. Common places that you would find this, it's all over the place. Things that tend to be normally distributed might be things like height, for example. You have sort of an average height, and then as you get taller and taller and taller, you'll find fewer people that are that height. You'd have your NBA players out here, right? And then as you get shorter and shorter and shorter, you have fewer people as well. There's lots of different things that would fit into a normal distribution or would fit close to a normal distribution. And since you would expect most of your people to be about average, that's sort of how this works out. Test scores, intelligence, all kinds of different things that you would measure would probably be close to a normal distribution. So what this says, 68% of the data is within one standard deviation. Remember that the standard deviation is just a number. It's a statistic that you get from a data set that describes how spread out it is. If you add that number to the mean and you subtract that number from the mean, then those two boundaries, between there, you would find 68% of the data. If you were to add that number twice to the mean, that would be going up 2 standard deviations, or subtract that number twice from the mean, going down 2 standard deviations. Between here, you'll find 95% of the data. And you can tell that looks about right. I mean, that's most of the data there. If you go out 3 standard deviations in either direction, that's 99.7. Virtually all of the data is between there. Only 0.3% would be left beyond that point. Okay, so out here and out here. Okay. As we do problems and we answer questions based on this, it's helpful a lot of times to break this down even further. The empirical rule simply states these 3 things. However, because it's symmetrical, we can do a little more with that. So look at this middle section. We said this was 68%. Well, that means each of these, which have to be equal to each other, they're halves, must be half of 68, which means this is 34% and this is 34%. Okay? Going a step further, if this is 68 and this is 95, if I subtract 68 from 95, that gives me 27. That means these two together have to add up to 27%. So each one is half of 27%, which is 13.5%. All right. Using the same kind of reasoning, this is 95%. Everything out to here is 99.7%. So what's the difference in these? 4.7. So this part here accounts for 4.7%. So half of that is 2.35%. These are numbers that are not explicitly stated in the empirical rule, but they are true because of the empirical rule. Now, if this is 99.7%, the whole thing's 100%. So that means everything to the right and left of the 3 standard deviation mark adds up to only 0.3%. So on each side, you've got half of that, 0.15%. This is much less than 1%. Okay, that's not 15%, that's 0.15%. 1% would be a 1 right here. So it's a very small amount, 0.15%. Okay, so I've got some problems here, a couple different questions we're going to answer based on this situation. There's a test that was given to 150 students. The average score, that's our mean, was 80 with a standard deviation of 4. Okay, so we're going to answer these questions. What percentage of students scored above an 80, between a 76 and an 84, between 80 and 88, between 68 and 84? And then we're also going to answer how many students scored below an 80, above an 88, and between a 72 and 88. Notice what the two questions are asking. Not only are the numbers different on some of them, but they're actually asking a slightly different question. The first part, A, says what percentage of students. B says how many students. That's a different question. We're going to have to answer it slightly differently. Okay. But before we do this, I find that it helps to, first of all, notice if the standard deviation is 4 and the mean is 80, if you add 4 to 80, you get 84. Well, that's one of the numbers I asked about, right? In fact, look at all the numbers that are asked about here. 76, that's 4 less than 80. 88, that's 4 plus 4 plus 80. So in other words, you've added 4 twice to 80 to get this. 68 is 12 less than 80. So everything is some multiple of 4 away from 80. You've added or subtracted 4 some number of times to get all of these different numbers. That's not always going to happen, and when we get problems like that, we're going to have to use a different technique. But when we have data that's exactly some number of standard deviations, again, the standard deviation is 4 in this case, if we're counting by 4s and adding or subtracting that amount, we can answer questions using the empirical rule. Okay, so it might help to do a little sketch of the empirical rule when you get a problem like this. And here's our mean, and that's 80. Okay, there's 1 standard deviation, 2 standard deviations, 3 standard deviations. Let's see, that's 1 standard deviation, 2 standard deviations, then we'll do 3. Probably should have spaced it out a little better. That's okay. All right, so if I go up 1 standard deviation, that's 84. This is 88, and this is 92. This is 4 less. This is 76, 72, and 68. These are the test scores, okay? This is how the test scores line up with the empirical rule. Now, we don't necessarily need to put the percentages on here. We can refer to our other picture for that. But it helps to sort of list it out so you can really get a graphical sense of where these numbers are relative to each other. So above 80, that means from here or to the right. What percentage of students would be above 80? Well, since 80 is in the middle, half of the students are above and half of the students are below. Okay, so that would be 50%. What percentage are between 76 and 84? 76 is 1 standard deviation below the mean. 84 is 1 standard deviation above the mean. So that means we are within 1 standard deviation. Going back to our chart, we're between here. It's 34 plus 34, or it's just 68. Because these boundaries are exactly 1 standard deviation less and 1 standard deviation more than the mean. So that's the middle 68%. Between 80 and 88, that's from the mean up to 2 standard deviations above, okay? There's a couple ways you could think about this. Let's look at the other picture. We're going from here to here, okay? You could simply add these percentages together. It'd be 47.5. Or you could actually go 2 standard deviations to the right and 2 standard deviations to the left, and then that's 95%. Just cut that in half. So there's a couple options to how you can think about each one of these. Half of that is also 47.5. Probably easier if you know the percentage just to go ahead and add these two together. 47.5%. Between 68 and 84. Well, here's 68 and here's 84. So that means we're going 1, 2, 3 standard deviations to the left. That's minus 3. And we're going 1 standard deviation to the right. Okay, between here. So there's a couple options again. We can either say, since we're going from 1, 2, 3, we're going from here to here. Okay. We can say, just add these all up, which might be the easiest way to do it. You know that this is 68, so you could take the 68 and then add these two. Okay. However you do it, if you can put in your calculator, just add them all up. Okay. 2.35 plus 13.5 plus 34 plus 34 or plus 68. 83.85%. Okay, that's the percentage questions. Now the other questions are going to say how many students. Okay, many is not a percentage, although it's going to be based on a percentage. So the first thing we want to do here is figure out the percentage. What percentage were below 80? Below 80 is the other 50%. Okay, so that's 50%, but we want 50% of the total, which was 150 students. So what you're going to do is you're going to multiply, and you probably don't need a calculator for this, but let's do it anyway. 50%, which is 0.50, 50% times 150. That's 75. In other words, it's half of 150, half of the students. We have 75 students. I'm not putting a percent sign on there. This is the actual number of students that would have scored below 80. All right, above 88. All right, so above 88. That means from here to the right. So I need to figure out this percentage first. I need to do 2.35 plus 0.15. That's going to add up to 2.5%. So it's 2.5% of 150. So I'm going to do 0.025 times 150. Move the decimal to the right 2 times. 1, 2, that's 2.5%. 3.75 students. So not even 4 whole students. 3.75 students. Of course, you can't actually have 0.75 students, but in statistics, we can talk about it that way. All right, between 72 and 88. So that's 2 standard deviations to the left and 2 standard deviations to the right. So we can actually just say within 2 standard deviations. And if you remember your empirical rule, that's 95%. Okay, from 2 to the left and 2 to the right, that's 95%. So we need to do 95% of 150. 0.95 times 150. 142.5. Almost everybody. And that's how we do empirical rule word problems.